now have our final method of factoring that we're going to focus on, which is the sum and difference of two cubes, as you see right here. Remember, the difference of two squares is factorable, but with the sum of two squares we couldn't factor. Now with the sum of two cubes we can factor it. Both of these will factor into a binomial times a trinomial, and we use this acronym SOAP to help us understand the pattern. SOAP is going to stand for same, opposite, and then the words always positive. And that helps us to understand how to deal with the signs in these different parentheses. Notice when we have a cubed plus b cubed, we have the same sign, the plus in our first parentheses, and for a cubed minus b cubed, we have the same sign, minus, in our first parentheses also. Then each of these second parentheses begins with an a squared, and then we have the opposite sign. The plus here switches to a minus as the minus switches to a positive. And then we have AB, the product of the two numbers inside the first parentheses, and always positive refers to a plus b squared, which is always positive. So here we go. Let's start in with our formula. We look at problem number 1. We see x cubed plus 125. We recognize that we have the cube of x and the cube of 5. If you want to rewrite your formula here, a plus b times a squared, not plus, switch the sign, minus ab plus b squared, you can. Notice how I kept the same sign, then I switched to the opposite sign, and then I had always positive plus b cubed. And I can now swap out the a for the x, swap out the b for a 5, and have x plus 5 in the first parentheses. The a squared becomes x squared. Minus is automatically in the second parentheses there. AB says multiply this x and 5 together, giving us 5x. Plus b squared becomes plus 5 squared, which is 25. And that is our answer. This second parentheses will not factor further. If it could have factored further, we would have given you a different formula to start the problem off with. Okay, let's look at number 2 here. I notice that we have the cube of y and the cube of 4. I'm going to have a minus b using the same sign, minus. Begin my second parentheses with a squared, then have the opposite sign, plus the product a of b, and then always positive plus b squared. SOAP. The a and the b get replaced with the y and the 4, and so our first parentheses is y minus 4. The second parentheses, the a squared gets replaced with a y, becoming y squared. Plus is automatically there. The a and the b are the y and the 4, giving us 4y plus 4 squared, which is 16. Okay. Now we have 8x cubed minus 1. We notice that 8 is the cube of 2, so 2x cubed, quantity cubed, makes that 8x cubed, and 1 cubed is 1. So first parentheses, 2x, same sign, minus 1. Then I've got a squared, which becomes 2x quantity squared, which needs to be 4x squared. And notice how when you multiply all this together to check your answer, 2 times 4 makes the 8. You need that. We're going to have the opposite sign, a plus in the next parentheses. The product AB, which is 2x times 1, making 2x. Plus b squared, which is 1 squared, which is 1, and that second parentheses won't factor any further. Okay, 3 goes into 81. I always want to ask, can I factor out a greatest common factor? And I can. 3 divides out, leaving you with x cubed plus 27. Now we're going to look at an x and a 3 as the cube roots of each of those. leave the 3 out front. My first parentheses will have the same sign, so x plus 3. Second parentheses will begin with x squared. We'll have the opposite over opposite sign. X times 3 makes 3x, and 3 times 9 makes the 27, or 3 squared makes 9. And so there's our product. Now, what if you forget these formulas? Well, there is another way out. Remember that we know how to divide polynomials. If we take that last problem, I would hope that with x cubed plus 27 you'd at least remember the x plus 3 part. You could take the x cubed plus 0x squared plus 0x plus 27 and do some long division with the x plus 3, and you should find that the x squared minus 3x plus 9 is what you get as your quotient. So you really are without excuse in terms of memorizing this formula. There is another way through this process.